Hi everyone, this is an overview of the separation of a ternary mixture laboratory experiment. The main objective of this lab is to take a solid, which is composed of three substances, and to separate each of those substances so you know the percent of each compound in the mixture. So in doing that, you're going to learn about chemical and physical separation processes and some techniques such as filtration and evaporation, how to use a Bunsen burner, and things like that. So let's start off right here. The first step is you take a beaker and take some of your mixture and weigh it out precisely and write that down. So in this mixture, I'm just going to write some notes here to help you visualize what's going on. We're going to have three compounds in here. Silicon dioxide, which is the main component of sand and glass, sodium chloride, which is table salt, and calcium carbonate, which is what limestone is made out of. So in these substances, they're mixed together, and it's called a ternary mixture because there's three of them. And our goal is to separate out each one. So let's start with really simple property of matter is to dissolve something in water. So you're going to add water to this, add H2O, okay? And one of these will dissolve in water, but the others will not. So which one of these is water soluble? Is it sand, salt, or calcium carbonate? All right, so what it'll look like is we'll have water, liquid water in here with the particles dissolved for one thing, and then the other particles will stay at the bottom of this, which is what we call a precipitate. Okay, so you've got your precipitate and you've got the component that dissolves in water. This component that dissolves in water is going to be your salt. So NaCl will be floating around in water. It'll be dissolved in water, not just floating around. So that we would call aqueous sodium chloride. Aqueous is a term we use for dissolved in water. Then down here, you're going to have your two other compounds, silicon dioxide and calcium carbonate. These are the compounds that are insoluble or not soluble, that don't dissolve. Next, you're going to separate the solid from the liquid, the solid from the aqueous layer, by using filtration. The filtration will, the setup for that includes a filtration flask right here, filter flask, and then a funnel. And you'll have a black rubber gasket right there to make a good seal between the two pieces, and you'll have this Buchner funnel up here. You'll put a filter paper in here, a circular one that fits in the funnel. This is cylindrical shaped. You're going to take all the contents of this and pour it into the funnel. So we'll take everything in here, swirl it around, and really try to get all of the contents in here. You're going to rinse it with water, a little bit of water, just to make sure everything gets transferred over. And what you'll notice is the liquid will go through, so that's the aqueous sodium chloride. So here that is. The little dots are representing the particles of sodium chloride or salt that are dissolved. So this is the NaCl. Up here is the solid that gets stuck in the funnel. So that solid I'll represent up here. And so right here will be the SiO2 plus CaCO2, CaCO3. All right, our next goal is to take all the liquid contents, the aqueous sodium chloride, and we're going to pour it into a separate beaker. So there it is. And then what you'll do is you want just the salt. Remember, our goal is to separate these three solids into separate components. So we want the salt by itself. In this case here, we're at salt and water. So to separate the salt from the water, we're going to use evaporation. And actually, we're going to boil the water and just get the salt in here without the water. Now, the salt's going to be everywhere. It's going to be all along the sides of the beaker. Also, when you boil something using a Bunsen burner, it's sort of high heat and the salt tends to pop out once it gets dry. So we recommend using a watch glass, which is a piece of glass, to go over here. You're going to weigh everything here, and then you're going to weigh it again when the water has escaped. And by doing that, the difference will give you the mass of the NaCl. So you're going to measure, eventually you're going to get the grams of NaCl, and then you're going to know based on the grams of salt divided by the grams of the total times 100, you're going to get the percent of just the salt. Okay, so there's that part. Now, we also want to know what's the percent of SiO2 and what's the percent of CaCO3. So actually, we know all three of these add up to 100%. So we only need to separate out two, and then we can use subtraction and find the third. So here's what we're going to do. We're going to use a chemical process. Now, before I used a physical process, which was dissolving salt in water. That's called physical because it's still salt. Even if it's dissolved in water, it's still NaCl. Chemical change is where you have a substance change into other chemicals. Okay, so for example, CaCO3 reacts with acid. So I'm going to use that and react away all the CaCO3 into different substances, and then take that silicon dioxide that's left, and that will be my second component. So what I'll do is, remember I took the filtrate down here, that's called a filtrate. I took it and evaporated the water away, that gave me my salt. Now up here I have the SiO2 and the CaCO3. So I'm going to carefully take that solid, it's going to be stuck on the filter paper. I'm going to put it into an evaporating dish, which is a shallow dish, usually made out of porcelain or something like that, so ceramic. So I'm going to take that, I'm going to put it into this evaporating dish. And the filter paper may also be in there. You can just put the whole thing into this dish and carefully add hydrochloric acid, HCl. Now, HCl is going to do a reaction with the CaCO3, and it's going to turn into stuff that is not solid anymore. But what is solid is your SiO2. It does not react with acid. In fact, geologists do this experiment to test if they have limestone, which is CaCO3, or if they have silicon dioxide, which is like quartz. And they do that by putting acid on it, and if it bubbles, they know it's CaCO3. So the calcium carbonate, CaCO3, is going to react with the acid, and then you're going to be left with only the silicon dioxide at the end, SiO2. Okay, so before you had the filter paper, you had the silicon dioxide solid, you had the calcium carbonate solid, you had everything as before except for the NaCl, which we separated out. Here we're adding acid. The CaCO3 will react with the acid and turn into other stuff, which you'll learn more about those chemical reactions later in the quarter. We're going to be left with just the silicon dioxide solid, but we're still going to have a lot of those liquids with the calcium carbonate products. So we don't want all that stuff. So you're going to decant or pour off all those liquids from your silicon dioxide. So we're going to pour off the liquids. I'm going to write decant. And then you're going to end up with an evaporating dish that will have just your silicon dioxide solid in it. Now it's still going to be sort of wet. You're still going to have water in there. So we recommend taking a Bunsen burner at low flame, and so sort of like the yellow flame, or not so blue, and you're going to sort of heat around this evaporating dish just to try to evaporate the water. Another good option is to put it in the oven, and I'll have the oven on. You could have just a nice drying from in the oven as well while you clean up all the other stuff. If you use your Bunsen burner, I recommend, again, having a weighed watch glass on top, because those sand particles are going to be popping out, and you don't want to lose that. You want to weigh how much that is. So in the end, you should know how much this whole thing weighed before you heated it, and then, you should know how much this whole thing weighed before you put anything in it. So if you have the empty evaporating dish and the clean watch glass, weigh those two things. Then when you have the sand in there and it dries, you want to know just the weight of that dried sand. So you're going to take the total mass here when it's dried, after it's dried, and then you're going to subtract the dish and the watch glass if you used one. So that's going to give you, the difference is going to give you the grams of silicon dioxide, which will be divided by the total mass of your mixture at the beginning, and then multiply by 100, get the percent. So we know all three of these equals 100%. So you know the percent of NaCl, percent of SiO2. That should give you the percent of CaCO3 when you subtract by 100. I hope this helps.